Hey, I'm Ryan from ngrok, and today I'm chatting with my teammate Sam Rose about what I think is his most ambitious interactive essay yet because of the quite extraordinary infrastructure he's building to make it possible. And if you haven't seen any of Sam's work, I highly recommend heading over to the ngrok blog to check it out because his posts just really are next level. So Sam, what is it that you've been building?
I'm making a Kubernetes cluster that runs in the browser. And there's good reasons. I promise there's good reasons for this. I'm not just losing my mind. So when we kind of make content at ngrok, at least kind of the content I'm making at the moment, we will talk a whole bunch about what we want to talk about. Very meta. We have previously spoken about, we've done some AI topics. So I did prompt caching. So that stemmed from this idea of, you look at the pricing page on OpenAI and Anthropic and things like this, and they've got like input tokens and output tokens, and those are reasonably easy to reason about. And then there's cached tokens. And I always wondered, I was like, what does that mean? What do you mean a cached token? Like, is that fundamentally different in some way to the rest of them? So I just had to kind of answer that question for myself. And then the blog post fell out of that investigation. Then quantization, kind of similar. Like I'd heard of quantization. I had no idea what it was or how it worked. And I wanted to figure it out and then write something about that. And that ended up being way more interesting than I realized because quantization actually goes back a long time. And this is similar. So I have a lot of experience with Kubernetes myself. I've managed clusters at previous companies. In a previous life, I didn't just write blog posts for a living. I was doing, in the trenches kind of work. And something I encountered a bunch of times in my career was probing in Kubernetes. The idea of sending requests to your containers on a periodic basis to make sure they are still healthy and able to serve requests. And there's a bunch of different types of probes. People tend to, I think, set their probing configuration when they first set up their jobs and never think about it ever again. And probably, and this is maybe, I don't know if I'm outing myself here, but I've seen this many times where the probing configuration is the same. So you'll have a readiness probe and a liveness probe. And the difference is not tremendously relevant. If you don't know the differences, it's okay. But there's these two different types of probes. They'll hit the same endpoint in the container every like 10 seconds. And sometimes what will happen is people will change this because rollouts are taking too long. So you've got like 100 replicas and each one needs to wait for the readiness checks to happen. So people may like reduce the period between them. But broadly speaking, I think not a lot of thought goes into this. And I'm like, should there be thought into, like, does it make a difference? Because I have had incidents in the past, not caused by probing, but where probing didn't help. So things will go down and the probing configuration that we set up was not the optimal. And it kind of would reduce the kind of mean time to recovery for that incident.
So for those who aren't familiar, what's the difference between a liveness and a readiness probe? And is this something that developers as well as cluster admins should know?
I would imagine a lot of people kind of like maintaining clusters. You can DevOps team it in for people. They know the difference, like most of them, I would say. App developers whose jobs get scheduled into the cluster, and I think in a lot of companies these are not the same people. So you'll have people who manage the cluster, then you'll have app developers who are writing code that runs in the cluster. I think a lot of them don't know, and for a lot of them it doesn't necessarily matter. Like a lot of them probably aren't working much on the health endpoints. And again, for a lot of companies, the health endpoint just returns a bog standard kind of 200 OK, and it doesn't do anything clever. And it's not obvious to me if that's the right choice, and we'll get to that in a bit. But the difference between liveness and readiness is in what happens when it fails. So let's say every 10 seconds, you're sending a request for each of these types of checks. So 2 requests every 10 seconds, and it hits an endpoint. And if the endpoint returns 200, everything's fine. If it returns a failing status code, so kind of like 400 and higher, when the readiness check fails, the pod is removed from any kind of load balancers. So for example, if you had some ingress configured, ingresses tend to link up with services, which then load balance traffic across groups of pods. When the readiness check is failing, the pod will stop receiving traffic in that way. And but it will stay alive. It's allowed to kind of stay there, and the assumption is that when the readiness check fails, it is some problem that should be resolvable without restarting the container. Liveness is a check that when it fails, the container itself is kind of forcibly restarted. And I say forcibly, it goes through the normal kind of termination life cycle in Kubernetes. So it will first receive a signal to terminate, and then a configurable period later, it will be actually forcibly killed off and restarted. So the effects are different, and it's a fairly important distinction, because I think restarting a container in a period of difficulty, so maybe you're kind of approaching overload, or something is not quite working correctly in your setup, restarting containers can actually be like the opposite of what you want to do, and it could cause more problems. But then similarly, if you aren't doing that and you're in a situation where you've only configured a readiness check and your pods are starting to become not ready for whatever reason, and there's no way they themselves can figure it out, they do actually need a restart, then that's bad as well. That's you end up in a situation maybe where some condition spreads throughout all of your pods, and all of a sudden all of them have been removed from the load balancer and none of your traffic is being served by anything. So it is the kind of thing that should demand a lot of thought from people, and historically in some companies I've worked for, it's not really had a lot of thought given to it.
So was that the inspiration for the post? So folks could learn to use probes more effectively?
As with a lot of stuff I have written, it is mostly personal curiosity. I would personally like to understand better. What is the answer? Like, how should you be probing? It would surprise me if the optimal answer is configure liveness and readiness to hit the same endpoint on the same period. Like, it would be surprising if that's the case. If it is, wonderful. But I would like to have done the work required to know that for sure. And I haven't done that myself. So scratching personal itches is a huge driver of what I want to write about generally. And ngrok has been really good about allowing that to be a heavily weighted factor into the decisions that we make. So I think there is some belief up the reporting chain above me that the best work comes from people working on problems that actually interest them in an environment where they kind of have the space to explore to the depth that they want to. And in previous jobs, I have had problems where, so for example, I can remember an outage we had where a confluence of things came together. And one of the problems that compounded with a bunch of other problems was we had inadvertently, without realizing several months previously, broken the reconnection code for our Redis cluster. So if a pod lost connection to Redis, the code that should reconnect it to Redis had broken, and we didn't realize. So we ended up in that situation where we didn't have liveness probes configured, or the liveness probe was hitting an endpoint that wasn't verifying that it could connect to Redis. And excuse me, in that setup, Redis was required for every authenticated endpoint because it's where we kept our session information. So almost every authenticated request would have to go and request the session information to verify that the user was logged in and who it was. But we ended up in a situation where the pods were slowly losing connection to Redis. There was some other problem with our Redis that surfaced this as a problem. And just over time, none of our pods could serve anymore. And it was just a completely lame cluster that wasn't doing anything. And it was identified in the post-mortem for that, proper liveness checking would have helped here. Like, they would have restarted, they would have regained their Redis connection. Things would have still been unhealthy, but it would have been a much more graceful degradation of service.
So once you've identified a topic that you want to write about, what does your creative process look like? Because your posts are well beyond a typical blog post that's just text and images.
Yeah, I'm glad you said that, actually, going well beyond. So back in 2023 or something like that, up until that point, I had been a back-end developer or DevOps engineer at companies for over 10 years. And I hadn't done much with front-end stuff, front-end web. I hadn't done a lot of actual website development before. I could write HTML, I could write CSS. I really didn't know what I was doing. Nothing I produced looked nice. It was all very kind of Spartan. And I didn't understand the web platform, as it were. But I had really loved the work of a guy called Bartosz Chrzanowski. He is an incredible content creator. He creates like one post a year, and he has this incredible post on mechanical watches. And what he has done in that post, and the first thing he showcases at the start of that post, is a full 3D exploded rendering of a mechanical watch, in which, as far as I can tell, it is not an animation, like it's an actual physical simulation. It is physically doing the things it needs to be doing to be a watch in the browser. And it blew me away. I could not believe what I was seeing. And I read through this post, and this post is long. It is like, you really want to be like blocking off a few hours in your calendar to go through it. And I didn't really care about mechanical watches, but I read that post start to finish in one go, and just the sheer quality of what he had built there really made me care, and it gave me this spark of inspiration of the web platform is incredible, actually. Like, there's so much you can do with the web. It doesn't just have to be replicating books. Like, it can be much, much more than that. Excuse me. And I got to wondering, like, what if that but programming? Like, what if could I apply the same methodology to things I find interesting in the world of programming? So I did a post about load balancing, and established a lot of kind of practices in that post back in 2023 that I've carried forward. And one of the key ones is, in that post, I have actual simulations of load balancing. So under the hood, I've written the load balancing algorithms. I've written this sort of simulated environment that can send requests to servers, but they're just kind of blobs on the screen. And that notion of simulation has stuck with me. And it's the kind of the content I have the most fun writing is, let's simulate something in the browser, and then from the simulation, I can attach visuals on top of it in whatever way makes the most sense to try and explain the topic at hand. And that neatly leads back to this probing thing, where I was like, okay, could we simulate probing in the browser? And I began looking into how I might do that. The actual probing code in Kubernetes is split across quite a number of files. It touches quite a number of systems in Kubernetes. It primarily happens on this component of Kubernetes called the kubelet. So the kubelet is a process that runs on each node of your cluster, and it is responsible for running pods, killing pods, cleaning them up, stuff like that. But it's also responsible for probing the pods. It's the thing that sends the request to the pods to make sure they're healthy. But it's spread across a lot of files. Quite a lot of code is involved in it. And I read it, and I tried my best to understand it, and I think I do have a pretty good understanding of it, but it just encompasses so many different systems in Kubernetes that I got this sense that trying to extract it out into a standalone thing was, I didn't have the sense I would have any confidence in its accuracy. And I had this goal and this idea in my head that it would be really nice to let people like input their own probing configurations in some way and see, like, how would your probing config handle this failure scenario? So to simulate a bunch of failure scenarios where different things happen, it's like, would your probing config help or hinder the situation? So to add a bit of like, that's something I've developed over time with some of my other posts is I think posts hit harder when it can invest in them. So like something that is goes into them. And I did a post a while back on queuing, where I tried to take this idea quite far, where most interactions you have with that post impact what happens later on in the post. So the way that you send requests impacts some of the data visualization later on in the post. So I like this idea of like, you've invested some time and energy into the post, and the post takes that energy and does something useful with it. It would be great if like we do something like that. So how well does your probing config stand up to these failure scenarios?
So how did you go from writing a post about Kubernetes probes to then needing Kubernetes in the browser?
Yeah, I when I realized that I wasn't going to be happy with trying to create like a facsimile of probing, the idea began tickling me, which was like, what if I just actually made a Kubernetes implementation that worked in the browser? And I started to think about like, how would that work? Is this completely absurd? I think the answer is yes, but I also think it's possible. I started off with a proof of concept, which was pure AI slop. I spent a couple of afternoons. I pointed AI at the Kubernetes repo, and I was like, I explained what I wanted to do. I was like, could you write in TypeScript all the components of Kubernetes involved in probing that runs in the browser? Then I wrapped a React component around that, and I got really encouraging results. So it spat out like 5,000 lines of pure garbage TypeScript at me. But when visualized in the browser, I recognized what I was looking at as probing, and I dug into the code, and I could kind of match up some bits here and there to the counterparts in Kubernetes, but it had done a very poor job. There was a lot of it had taken a lot of weird shortcuts. It had moved things around in odd ways. Some components that are responsible for something in the Kubernetes code base were now responsible for several other things that they maybe shouldn't be. It wasn't a good port. It wasn't, it didn't seem easy to me to verify that this thing was accurate. So I threw it all away. I was like, okay, what I am taking from this is the energy to continue. So I started again from scratch. And I, shock horror, began writing a bunch of code by hand. And I started at the kind of foundational layer. Excuse me. There was actually a bit of a pause between the two implementations where something else I realized reading through the code that AI had generated for me was I actually don't have a good sense of the shape of Kubernetes from an internals perspective. I've used Kubernetes, I've managed Kubernetes in production, but I didn't know what are the pieces that kind of come together to make a Kubernetes, So I bought a book on Kubernetes internals and I read through it, and I spent some time in the Kubernetes code base, and I got more of an understanding of what it is. And ultimately, at the very core is a database of resources. And this is stored in a database called etcd. So I started there. And I knew something that I wanted to be able to do. So I started off writing it by hand because I don't think AI does a great job of architecturally creating a big project. So I wanted to set the architecture and the shape of the project myself. And I created the initial boundaries. I wanted API compatibility with Kubernetes. And in my head in the beginning, what this meant was there is a component of Kubernetes called the API server. It's just an HTTP server, nothing weird and wonderful, that you send JSON and it sends JSON back, right? Just an API, nothing complex. And that's what you talk to when you're using kubectl on the command line. You say kubectl get pods. That's sending a GET request to the API server to get the pods. And it very, if you looked at it, you'd recognize it. If you'd done anything like that before, it's not magical. And initially I was like, right, I will match that API. The problem I ran into with that was actually exposing an HTTP API in front-end browser code is a real pain. Because there's a lot of tools I would like to have reached for, I couldn't reach for. Express, it's a node library. There is a URL pattern matching web API built into the browsers, but it's not tremendously nice to use. There's also other libraries out there you could use for doing kind of URL routing and things like that. But it ended up feeling like a ton of effort. And it also, because I was doing this in TypeScript, it didn't confer much type safety. And I ended up reaching for the Kubernetes Node.js client library. So the Node.js client library, admittedly, it's actually not a very nice library to use. No offense to the people who make it, it's a bit of a pain to work with, but it is a TypeScript library that has types on all of its surfaces, which means I had the benefit of TypeScript telling me when things go wrong. So I decided that would be my API surface. And what I did was I began implementing, because it's all generated with an open API spec under the hood. So I began taking a method at a time and implementing my version of it that was perfectly type compatible with the JavaScript API for Kubernetes. And the benefit this gave me was I was able to write tests that ran against a real Kubernetes cluster running in K3s in Docker on my machine, and then run the exact same code because I had a type compatible library that was doing Kubernetes, and assert that I got the same results from my code. And now that's a fairly comprehensive test suite at this point. We're not recording this at the very start of the project. I am now several weeks into this. But I have this type compatible API layer, and I've been just steadily expanding that and getting to points where, let's say, for example, creating node resources is real simple. Like the node resource, not really a lot to it. And I could essentially hard code that my cluster will always have 3 nodes. And I left it at that. And I automatically kind of create these 3 node records at the beginning when I bootstrap my cluster. But then you get to like pods, and it's like, okay, pods require kubelets, and then kubelets require a container runtime. And I don't have a container runtime because I am in the browser. There is no container runtime here. What do you do? And I couldn't run real containers. I think there's ways of doing it. People have linked me to like, yeah, you can run them in a WASM runtime. And I'm like, I don't think that's a good idea, man. Another thing with the whole project is, because people were saying to me as well, like, you could compile the Kubernetes project to WASM, that you take the Go and compile it to WASM. I'm like, that's like, it's going to be like a 70 megabyte bundle. Like, it's too big for the blog post. This needs to be something that doesn't announce itself. Like, I don't want people to sit there with like a loading screen for ages downloading a thing. I want it to just kind of work without much ceremony. So, the container runtime ended up being, I have this API that I've created for defining images, and my cluster has its own little image registry. It's just a map of string to images. And because I'm doing all my testing through what I call these parity tests, where the same code runs against K3S and my simulator, I am creating images that match the behavior of real images. So, for example, I have a BusyBox image, and BusyBox is a container in the real world that contains a bunch of tools like wget and stuff like that. So when I run these parity tests, the real K3S downloads the real BusyBox and does real things with, like, it runs the actual wget to test like DNS resolution within the cluster. My simulated version of this, I have a class that represents the BusyBox image, and it has an exec function that takes a set of arguments that is just like wget space some URL, and I do stuff that makes sense for the cluster. Like I have a whole like cluster network class that I can then do like a fetch into, and it does DNS resolution within the cluster, but it's all kind of simulated and fake. But it just means that I can run tests that do the exact same thing in two different environments that get the same result. And the more I talk about it with you here, the more I'm thinking this must sound just completely absurd. Surely this was not the easiest way of doing this. And the answer to that question is no. But I think there are some secondary benefits to doing it this way. Like the first one, sorry, go on.
I can imagine people listening to this thinking, wait, ngrok let you build Kubernetes in the browser just for a single blog post?
I will indemnify my boss and say that at several points in this project, he was given the opportunity to say no. I encouraged him a couple of points to say no, but he thought it was a great idea. Well, I don't know, maybe. He thought it was an idea worth pursuing. I don't know, great's the right word. It slowly happened and then happened all at once. So I was exploring, and I have a very like biphasic way of working. So a lot of my content begins with a very long kind of like discovery and exploration period. So when I was doing quantization, for example, I spent a long time like renting GPUs, quantizing models myself, testing them, running benchmarks. I have this real like sticking point where I don't like writing about things unless I have firsthand experience of them. So I go and I get firsthand experience of them. And sometimes, I have not like quantize models and run them at scale. I have no outlet to do that. I don't have any product where that is required, but I try and get as much of the first-hand experience as I can with the situation that I'm in. And that's what I did here as well. So I was doing a bunch of trying to make simulations of probing and just like never feeling happy with it. And then, having a one-on-one with my boss every week and saying like, I really think the answer to this, and you're going to hate that. You're going to hate what I say, but I think the answer is it would be great to try and make an actual version of Kubernetes that runs in the browser. And then quickly before he can say anything after that, being like, and here is like the cell, right? Okay, there are great secondary benefits to this, or they could be. I was like, we'll have to open source it because the reason for doing it is accuracy. And then you can't just say, I built a Kubernetes cluster in the browser for accuracy. And by the way, no, you can't see it. No, that just completely defeats the purpose. So it will eventually be open source when it's ready. And that could lead to, if it's well executed and it's somewhat usable, other people might then use it and build content off it. And it might be a really nice tool for the Kubernetes community to build richer, more interactive Kubernetes content on the web, which would be lovely if people did that. Like there is a big goal here at ngrok for us to be providing value into the communities that we care about and we're building tools for. Kubernetes being a big one. We have our own kind of Kubernetes operator. ngrok works well in Kubernetes clusters. Like it's a product surface that we care deeply about. So giving back like this is something that's important to us. And also even if I had to sell even if it doesn't work, and the jury is still kind of somewhat out on that. So I did recently run my first kind of full tests of, this cluster running in the browser and doing things. And they were, touch wood, promising. Because one of my big concerns here was this is 20,000 lines of TypeScript at this point. There is a lot going on to kind of manage this cluster. And there's a lot of kind of periodic stuff just happening all the time while the cluster is running. Is it just going to tank browser performance? Is it going to feel terrible, make the page really laggy? Touch wood, that doesn't seem to be the case. It seems to work very well. I'll know more as the weeks go on. Hopefully we'll talk about that in the future.
Yeah, for sure. So have you thought about Kubernetes in the browser use cases beyond the blog post?
My dream is this becomes a kind of pedagogical artifact. It is its own teaching resource. It can help you learn how Kubernetes works under the hood. And the Kubernetes source code is obviously the source of truth for how Kubernetes works under the hood. It's a little hard to follow in places. I don't think, it doesn't have a goal of being easily understood necessarily. So there are certainly some gnarly parts of it. But I don't know, being in the browser and being able to visualize it in any way, shape, or form that you want it, in a way that doesn't require the user to download and run anything themselves. Just the browser is this ultimate zero friction environment. I just have to click on this link and it's all there. There's no extra steps. I think that's very powerful. And I think that does open the door to lots of potentially new types of content around Kubernetes. And being in the browser as well, you can throw a debug point wherever you want and you could stop it and inspect what's going on. You can hopefully add hooks wherever you want into it to kind of visualize different points. It's one of the things that's on my to-do list at the moment is to add a bunch of hooks into the network itself. So you can see how things move around the network in the cluster. These secondary benefits are all stuff that I'm hoping come to pass, because the other side of that coin is I write something based on top of this kind of engine, if you want, and no one cares. It wasn't a good idea. No one cares about probing. Not interesting. Move on. That's an outcome that I worry about, and I worry about that outcome with all of my posts. And in that case, how do we salvage that? Because this, fundamentally, ngrok's not a charity. I'm not being charitably paid to do this work. There does need to be some sort of return on investment, but there's plenty of content we can get out of hey, I tried to do this thing and these are decisions that I made. These are the mistakes that I made. These are the choices. That was part of the sell, is that this does kind of come because the level of absurdity is so high. It just kind of comes with this built-in insurance policy that we'll be able to squeeze something out of this that people will hopefully find interesting.
So with Kubernetes in the browser, you're not only changing the language from Go to TypeScript, but you're also changing the runtime environment as well. So what's been your approach to testing and verification?
I knew this would come up. So this is okay. I'm going to give away some behind the curtain. This is a leading question based on something I was talking about internally. So internally, I have been making kind of short vlog style videos for the company, and I post them into Slack, and I talk about kind of the trials and tribulations of doing something as wild as building a Kubernetes cluster in the browser. The most recent one I had, Go works differently to TypeScript. Headline news, should be more at 10. And I began with this philosophy of I am going to write TypeScript and I'm going to follow kind of TypeScript isms, which is fundamentally different to Go. So, for example, the way that Go does error handling, fundamentally different to TypeScript. And I adopted exceptions rather than error values. So a bunch of my TypeScript code that's based off the Go code looks a little bit different because it's doing a little bit of try catch here and there. But I thought that was the right call. And that still is the case. Like, I am still doing that, and I think that is still the right call, but I'm kind of leading into something here where another thing I was doing was Go has channels. If you're unfamiliar with channels, they are like little buffers that you can push messages into and pull messages out of. And Go has like actual language level syntax for doing this, such that like you can try and pull from a channel that has nothing in it, and that will block until something is in the channel. So you get this kind of message passing functionality that's very kind of core to the language. Channels are very widely used for lots of different purposes. This is something I didn't have access to in TypeScript. I don't have channels. So I decided to go with my kind of like TypeScript isms philosophy. And I was like, I'm going to use event emitters instead, and the event system rather than channels. And that was working real okay for a while until I got to the point where there are several places in Kubernetes where a component will select over multiple channels. So what does that mean? When you select over multiple channels, you are effectively saying, take these 3 channels, and it looks like a switch case statement. So you say select, and then you have a case for reading from this channel, case for reading from that channel, and that will evaluate whichever channel has a message available first, basically. So it's a little more nuance than that, but that's basically what it does. And it will block until something gets a message. Kind of challenging, actually, to try and listen to 3 different event emitters in the same way. I hacked something together, and I didn't feel good about it. And I was sat there. This was actually just a couple of days ago. I sat there like, I need channels, really. I kind of do actually really need channels here. And then I was like, can I make a channel-like abstraction in TypeScript? Does it make sense to do so? And I did do that yesterday. So I have made my own channel abstraction. It has selects. It doesn't work exactly like Go does, but I ended up doing a bunch of refactoring of the different parts that I had hacked in event emitters to do the same job. And it works, and all my tests pass, and the thing that I got working in the browser seems to work. And as a result, the Go code, the TypeScript code looks now a lot more like the Go code, and I'm able to get like much more. There are sections of the code base which are literally like transliterations of the Go code. Like, I'm using the same variable names. You can go through line by line and see this is just the Go code line by line in TypeScript, and that's very intentional. For all of the components relating to probing, it is transliteration of the Go code because I want it to be as accurate as it possibly can be. Now, is my channel abstraction semantically equivalent to Go channels? I ported over Go's own test. I actually, for channels, I didn't do this. For I built my own ticker. So Go has this notion of a ticker, which is just a channel that gets a message every n seconds, or like on a period. I built my own ticker based on channels, and I copied over Go's own ticker test suite to TypeScript. So I'm testing my tickers in TypeScript in the same way that Go does. But I also, for my channel tests, I wrote a sequence of Go programs that exercise channels in lots of different ways, and outputs. They're like little Go puzzles. Like, each one of them I could post on social media as a puzzle. Like, what is this output? It'd be kind of fun. But then I'm writing the equivalent TypeScript to that in tests, in like vtest tests, and asserting that the same thing happens in each of them. So I am going, I think, to a good level of rigor here on making sure these things behave in the same way. Ultimately, though, because TypeScript is single-threaded in the browser, it probably is never going to be 100% the same. I don't have access to any kind of thing like Go routines. I could do separate threads in the browser through web workers. I haven't got to that point yet. I did actually wonder to myself, would it make sense to spin up like a web worker for each container that we're running? And there's a part of me that wants to try that, but I haven't needed to yet. Like, nothing has like pushed my hand to need to do that. So in the interest of keeping things as simple as I can, I'm not doing that currently, but it's a road I can go down. And it's one of the like aces in my back pocket I've had, where if this is really slow and horrible in the browser, I can always try web workers and get more threads available to me. But that presents its own challenges. How do I make sure? Like, I am doing a lot of parity testing between Go, between Kubernetes, etcd as well. I didn't talk about. I have copied the Microsoft's etcd3 client library API. So I have quite a large suite of etcd tests that make sure it behaves in the same way as the real etcd does through this client library. I'm just trying my best to assert against reality wherever I possibly can.
Well, it seems like you've come a long way. Do you have a sense of how much further you've got to go?
Yeah, the next big step, the next immediate steps is I don't have support for replica sets or deployments yet. And that is the ability to deploy multiple pods in a group. Currently I'm just creating pods individually, but no one does that in reality. So I do want to have replica set and deployment support. And I do actually know from my previous Vibe Slop project, those are two very simple components to make. They're actually not that bad at all. So that will be some point, probably this week. It's Thursday. Maybe early next week. Then the next big thing is, while I can currently visualize the cluster in the browser nicely, and the way that I do that is the Kubernetes API has this notion of watching. So you can watch for changes across a specific resource. So I can watch for all pod changes, or I can watch for all pod changes on this specific node. So that maps nicely to React, because in React, I can have a cluster component and then a node component. In the node component, I can make sure I'm watching node changes there and updating stuff for that node. It's very nicely reactive. What I don't have is any notion of requests moving through the network. So all these watch points watch Kubernetes resources. I need some way to hook into the cluster network to know when a request is leaving one place and going to another place. So that is going to have to involve introducing pseudo network lag as well, because if I'm wanting to move points across the screen, that needs to take a defined amount of time. So I need to introduce simulated lag into the network and then fire events up that say a request is leaving from here and going to here, and it's going to take 500 milliseconds. And then I can do on the simulation, on the visualization of the browser, I can then move a point from there to there. And I know that when it gets to there at the end of the 500 milliseconds, then something is that request is going to be received by the thing, and something else is going to happen. Maybe it will trigger another request, and then I get another event that's another request now is leaving from here and going to over here. So I need those hook points into the network so that I can visualize what's happening within the network. That's the next big thing to tackle. Once I have that, I also haven't fully audited the probing code yet. I am using LLMs to do work here. LLMs are writing code for me. For all of the probing stuff, I have gone through maybe about 80% of it line by line, with the corresponding thing it's copying up on screen, and looking line by line and seeing do these things match? Are they correct? And there's a lot of things in the Go code that I've not copied across. So I don't have anything to do with volume storage. There's a lot of stuff in the Go code that's kind of gated by feature flags. And a lot of that stuff is actually default off now. So I've not copied that across. It's just old features that are deprecated now. I don't have any concept of ephemeral or init containers, and it's not important what they are. It's just other types of containers that can be within your pod. I've decided they're out of scope. So anything to do with those is not copied across. So it's a bit of a drag. It's very tedious work, just literally going through line by line and being yes, these things are equivalent. And then once I have done that, devising tests that there is externally verifiable behavior from K3S and my simulator that would make sure, yes, I have done that thing correctly. Which is a real pain with probing, because there's lots of tests I want to do where I need to simulate that the pod has failed in some way. And the way that I have been doing that is Kubernetes actually has a container called AGN host. They use it in their end-to-end tests. It exposes a bunch of utilities. So for example, it has an HTTP endpoint for running shell commands, which obviously you should never expose, but it's for testing purposes. So I have this container that the ready check reads if a file exists on disk, and if it does, it returns ready, and if it doesn't, it returns unhealthy. And I am running this endpoint shell commands, removing and re-adding this file to simulate readiness, stopping and being okay again. And that works in both K3s and my simulator in the way that it should. But it was just like a pain to get that set up because it requires me to be able to like simulate a file system, which I didn't have to do previously. And I was hoping to be able to avoid, but now that's the easiest way to achieve the thing that I want to do because I need some state in these containers. So yeah, like hitting a bunch of stuff like that is always a bit annoying because I'll say to Joel, like, yeah, this week I'm going to do this and hopefully get to this point. And then like 3 days go past and it's like, I'm making a file system. I didn't expect to be, but I have to. It makes sense. I promise. Please don't fire me. Yeah, I've forgotten what your question was. I feel like every question you've asked me, I just like completely veer off course. But sorry, what were you saying?
Can you share a bit about your development process? How much are you using AI? Is it writing code for you while you sleep?
Not that deep into it. I have tried my best at every point with the stuff I have been doing at ngrok professionally to be very grounded about these tools. So I think they are genuinely useful. They genuinely add value. I don't personally let them off the leash and like do loads of things for me while I'm asleep. Like that's too far for me. I work very synchronously with LLMs. I like that they can take away really dull, horrendous stuff. So I'm at the point now where there's enough structure in this project and I've got like agents files dotted around that explain the idea behind different directories and things like that. So for example, all the code involved in like mimicking the Node.js Kubernetes SDK is like fully LLMs at this point because it is literally match this type signature, bring these types across, stuff that it would just be drudgery to do that by hand. But I can say to an LLM, like, I want to implement the endpoint to delete namespaces. And I'm like, find out what that endpoint is called, go into this directory and implement all the kind of boilerplate stuff that we need to do to delete namespaces. And then it will kind of like hook into the actual code I care about, the stuff that kind of talks to etcd and stuff like that. And then I care from that boundary downwards. I'm like, all the boilerplate stuff, I don't care whatsoever. Like that I know that the TypeScript checks passing means that it is type compatible with the things that I care about. I don't have to look or care too hard about it. But then everything below that, the actual how it works, I'll let LLMs write that stuff, but I will go and have a look. And, very often I find the LLM has written totally like asinine code. Like just, it seems obsessed with things like backwards compatibility. I probably should put something in my agents file that's like, there's no need to care about that for the time being, but I just haven't got around to that. But it's just like, yeah, I'm going to keep this API surface so we don't break any consumers of this. And I'm like, no, there's no consumers, like, stop it. And it also like, it just doesn't seem to come up with great API surfaces. Like, there's the external API surface that is being validated for me by TypeScript. But then internally, like, as I'm working on this, I want nice internal APIs to work with, to kind of talk to etcd and talk to other components of the cluster. And it consistently comes up with like horrendously verbose names, and like it will create something I really hate is like temporal dependencies between function calls. I hate if like you have to call this before you call that, otherwise things don't work. And I catch it like all the time introducing temporal dependencies, and I'm like, no, merge these two things. It's silly. What are you doing? So yeah, I have a bit of a, I don't know, I'm not mean to it, but I'm very constantly like, don't do that. Let's do this instead. So yeah, I like to maintain a level of personal taste in the code and stuff that I like, which is, it's my project so far. It will eventually be open source and maybe other people will have opinions. It would be lovely if people did use this project and they liked it enough to contribute. I would be incredibly honored and grateful if that happened. So maybe at that point, somebody comes along and is like, all the way you've written this code makes no sense to me. But until then, I have this very strong sense of what I want it to look like. So I can guide the LLMs in that direction quite a lot. Have I read every single line in the code base? No. There is a lot of boilerplate. There's a lot of types. There's a lot of like API surface and that stuff. I just trust that TypeScript is correct. Because if I got a field wrong or the name of something wrong, TypeScript would error. And it's happened several times. It's really nice actually to watch. The LLM will bring some stuff across and then TypeScript will say that field name is wrong. That's wrong. That doesn't match the shape of that. And then the LLM is like, I'll go fix it. Sometimes it fixes it in awful ways. Like I've caught it, putting any's in places because the types didn't match up. And I'm like, no, I've had to reinforce several times in the agents.md files. Like the most important thing is type compatibility with this library. Like if you are ever in doubt, our code must change to match this type surface. So that it's been better since I've done that. So yeah, working a lot with LLMs. I'm on a pro subscription to Codex, and I would say I pretty rarely hit my limits. To give a sense of how much I am using these things. I'm definitely not a max subscriber, and I hear stories about people all the time hitting their max limits and opening a second max account to get $400 worth of tokens per month. I am absolutely nowhere near that level of usage.
Well, it's clear that you've approached this project like a craftsman. And because of the quality of your implementation, and also just because it's Kubernetes in the browser, I'm sure there'll be folks that will want to contribute and take it further.
Dude, I have that would make it for me. And it's being built in a way that's very optimistic. So I'm making sure, and before I release it, I will be writing a really detailed README on how would you extend this? How do you use this in practice? I want people to use this. That is what I am aiming for, and I'm understanding of the fact that the likelihood is low. This is a very harebrained idea. I think it would be very unlikely for other people to have the will to go in and do this. But I really hope they do. And anyone who would show interest, if someone came along being hey, I'm wanting to write a thing about Kubernetes here, and I think I could use our project for it. How do I get started? I'd be delighted to help somebody out to get them on board. A big fear would be, I'm putting all this effort in. It's one of the reasons this call is very scary to me. I don't often talk a huge amount about what I am doing before I have done it, for fear that it doesn't work out, and it would be catastrophic in my mind if this video is going to go out long before the post does, and then the post either gets shelved for whatever reason. That would be absolutely awful, or kind of releases and flops, and the community is this is stupid, you're stupid, why did you do this? And then the whole thing languishes and it just becomes abandonware. That's worst case scenario. I would hate for that to happen. So I am hoping that this level of care and this level of optimism that it can be something very useful is something that increases the likelihood of that coming to pass.
Yeah, I have no doubt that it'll take on a life of its own. And I can see huge potential as it being used as an educational tool to visually show how various components in Kubernetes work.
You have a much higher level of confidence than I do. And I'm getting energy for that, and it's great. I'm still, with all of my work, in my head, I'm this is silly. It's going to completely fail. Nobody's going to care. And, that has proven not to be true. And I'm very grateful that that's the case, because I do really pour myself into these projects. But it is inescapable for me. I think it is a fundamental flaw of my own character that before everything, as I'm working on all these projects, in the back of my mind, there's just this voice that's this can't possibly succeed. This is so dumb. So yeah, I really hope it does. I really hope people get value from it, and it's something that can be useful beyond the scope of ngrok. But we all it's another part of the investment in this is there is an understanding here that we're paying this upfront cost, but we should be able to get quite a lot of value from that. We could do a post on how the scheduler works. We could do a post on how different deployment types, different rollout types, there's a lot of configuration you can do with how deployments change versions, right? You have, I can't remember the names of any of them off the top of my head, but it's there's a surge capacity, and then there's how many are rolling out at the same time, and that interacts with probing. So that's something that it could be a really nice follow-on, because it interacts so directly with probing, because you have to wait for the pods to become ready and enter the load balancer before you kill the next one and try and roll something out. So there is this understanding kind of from a business perspective that this is an investment that we should be able to get a lot of value from in future posts. It's not just for this one thing. So yeah, hopefully this doing well should be a signal that you should expect more Kubernetes content from us.
Well, mate, this has been a fun chat. I've really enjoyed learning about your creative process, hearing about your adventures implementing Kubernetes in the browser, and also just seeing your passion for following your curiosity and educating others as a result. So it sounds like you've still got some things to do. So what do you say we do this again once you're a bit further down the road?
Yeah, I'd be up for it. I probably not as long next time. I think we this is a bottled up like amount of energy from like 3 or 4 weeks of working on a project. Like by next week, I will not have this much to say. But certainly, like there's been challenges that we've not spoken about, and there's going to be challenges that come up after this as well. So definitely talk about more of that stuff. And it's people have asked me a lot, like, I'd love to see you do a course on how you make these posts. And I'm like, I don't think there's a course, but maybe I can talk about it with Ryan for a bit more.
Yeah, for sure. And I can see us doing this for future content that you develop as well. All right, well, let's leave it there, and we'll pick it up in the next one.
Yeah, have a good evening, dude. Take it easy.
Thanks, Sam. You too.